Hello students, welcome to a tutorial session with Ms. Taylor. Today we are looking at an AP Chemistry topic, specifically balancing redox, better known as oxidation-reduction reactions, using the half reaction method, because some equations you simply cannot balance using the normal method. So you have to break it into halves, and this particular reaction takes place in acidic solution. And whenever you have to do a reaction that has to be done by half reactions, you have to know if it's acidic or basic so you know where to stop. So we'll get started first by assigning oxidation numbers to each of these species. So there are rules to these. We'll do the easy ones first, like oxygen is going to be a -2 here. We have a monoatomic ion, so it's -1. Hydrogen here is going to be +1. Another oxygen is -2. Another oxygen is -2. So let's go back and do the ones that we actually have to calculate. Alright, if this is -6, then this one must be +5 to give us a -1. The diarsenic trisulfide is a little trickier. The one that is going to be most electronegative is going to maintain its normal charge. So if we look over here to the periodic table, sulfur is both higher and farther to the right, so it is the more electronegative of the two. So we're going to assign it its normal -2, which means our arsenic is +3. Okay, and going back over here, we assign this one. Now we've got to solve for arsenic right here. Let's see, I have -8 and +2, which is going to give me -6. And in order to maintain a -1, I need this one to be +5. And then sulfate over here, this is -8, so that must be +6 to maintain that overall -2 charge on that polyatomic ion. Okay. So why did we do this? Well, some questions ask you to specifically state which is the oxidation half and which is the reduction half. So let's take a look at what happened. We had chlorine that went from +5 to -1. And then we had arsenic that went from +3 to +5. In order to go from +5 to -1, you have to gain electrons. So there's our reduction half. And to go from +3 to +5, you would have to lose electrons. So there's our oxidation half. Alright, so let's start with the reduction half. Alright, so chlorine is our species that is reduced. So we only need the chlorate ion from the reactants. I'm going to leave some space because we'll have to add some things here and there. And then chlorine only appears on the product side here as the chloride ion. Our oxidation half is going to be longer. Alright, I'm going to switch colors here. Okay, so once you've broken it into half reactions, the next thing you need to do is to balance all elements besides oxygen and hydrogen. And we're in luck this time because the number of chlorine atoms on each side is the same. So why did we keep oxygen and hydrogen for last? Well, because we have to balance them a special way. If you have oxygen atoms that are unbalanced, you're going to add water to take care of that. So since there are 3 oxygen atoms on our reactant side, I'm going to add 3 water molecules to the product side. So that's balanced. But now I've added hydrogen atoms to the product side. So to take care of that, on the reactant side, I'm going to add the needed number of hydrogen ions. That's 6, so I'm adding 6 hydrogen ions. And then before I declare this to be a balanced equation, or a balanced half reaction, I'm going to have to check the charges. So we have a -1 from this species, +6 from these species, so we've got a total of +5 on this side. Over here we have -1 and 0. So the only thing we can do is add electrons. So if this side is +5, we need to add electrons to make it -1, and so if we add 6 electrons, both sides have a -1 charge. You hear my dog in the background, I'm sorry. And now for the oxidation half. So everything else that we did not include in this half. So we've got diarsenic trisulfide. I'm going to leave a little bit of space here. And then we've got this interesting ion here. And a sulfate. Okay. And sorry, there was a little lag in the video. I paused it so that I could fix my water molecule and had some technical difficulties. Okay, so we were balancing the oxygen atoms. We did that by adding 20 water molecules to the reactant side. Now we need to balance all those hydrogen atoms. And so now we've got 40 hydrogen atoms that we added to this side, and we definitely do not have 40 on the product side. We only have 4. So we need to add 36. You're going, Miss Taylor, why did you pick this problem? It'll work out eventually. Okay, so now we need to check electrons, and this side is neutral. Okay. This side is definitely not neutral because we've got -2, -6, that's total -8, and then +36. So we're going to have to add quite a few electrons. We're actually going to have to add 28 electrons. I know, that's a lot of electrons, but again, we'll get them to wash out eventually. Okay? Alright, so let's scroll down a little bit here. Alright, and we're not done. We have to make the electrons cancel out. You're going, how are we going to do that? We have 6 on this side and we have 28 on that side. Well, we're going to have to multiply by a common factor so that we end up with the same number. In order to make the electrons match, we are going to have to multiply both halves. By what factor? Well, this top one's going to have to be multiplied by 14. And the bottom one is going to have to be multiplied by, punching this into my calculator again to make sure, by 3. Times 3. Okay. So now I'm going to sum these things. Draw the line there. Scroll down just a little bit. No, a little too much. And, okay. So, we have 14 chlorate ions plus 14 times 6 gives me 84 hydrogen ions. And we know that our electrons cancel out and we get this part of the reaction, this half. So 3 of these. 60 water molecules. And then arrow, and I'm going to write the products on the next line simply because there's so many of them. Alright, so 14 chloride ions. Then 14 times 3 gives me 42 water molecules. And then 6 of this. And 9 sulfates. And I'm about to run out of space. 36 times 3 gives me 108 hydrogen ions. Okay, now this is not our final answer, because some of this stuff most definitely cancels out. Okay, I'll take care of the water first. There is 60 on our reactant side and only 42 on the product side. So 60 minus 42 is 18. I'm going to mark that out. I'm going to change that to 18. And then on our hydrogen ions, we've got 84 here, 108 there. So I'm going to cancel that out. And let's see, 108 minus 84 leaves 24 hydrogen ions. And that should be the only things that can cancel. So I'm going to scroll down just a little bit more and write the final version of this equation. And I'm kind of glad that I picked this one to do and I did not work it out ahead of time. So you can probably hear that in my pauses and thinking. But it shows you that sometimes you get crazy numbers. I'm not going to have enough room. No, I'm going to drop to the second line to do that. That, ladies and gentlemen, is the balanced redox reaction in acidic solution. Hope you enjoyed watching. Best of luck to you.